Back. So now we can start problems on section 5.1. Problem 1. Find the area of the shaded region below. So you have a curve and you have a line. They intersect at 0, 0 and at 4, 4. Clearly the curve is above the line. So the shaded region, area of the shaded region is integration from x value 0 to x value 4 of the first function minus the second function. Okay, so integral 0 to 4, 0 to 4, that's the x coordinate, of the higher function, that is 5x minus x squared, minus the lower function, that is x. Simplifying, I get 4x minus x squared. Integral 0 to 4, 4x minus x squared. You find an antiderivative, 4x squared by 2 minus x cubed by 3. Limits are 0 to 4. Substitute 4. You don't need to substitute 0 because that's going to fetch you 0. So simplifying, all this comes to is 32 over 3. Okay, this is simple calculation. You can check for yourself. 32 divided by 3. Correct. Next. You are given two curves. One is in blue color, the other is in red color. One curve is x squared plus 2x plus 8. The other curve is 2x squared minus x minus 2. We do not know which one of these is the red or the blue. Okay. The question is to find the area of the region enclosed. So they want the region that is closed between the two curves. So that's the enclosed region. So basically we need to find out which one is the blue one. That's the higher level curve. And the red one is the lower one. So before we understand that, we need to find out the intersection points. All right. So the two curves in question are x squared plus 2x plus 8 and 2x squared minus x minus 2. Y equals this and y equals this. All right. We have two intersection points. So how do we find the intersection points? Set the expressions defining the curves equal. All right. So 2x squared minus x minus 2 is x squared plus 2x plus 8. Move every term to the left equals 0. That fetches me eventually x squared minus 3x minus 10 is 0. Factoring it gets me x minus 5, x plus 2 is 0. Which means this factor gives me x equals negative 2. This factor gets me x equals positive 5. Now the question is, which curve is above? You see, we found the x coordinates of the intersection points. All right, these are the x coordinates of the intersection points. So that point will have x coordinate negative 2. This point will have x coordinate positive 5. Okay. Now, so you consider the interval negative 2 to 5. Choose any number between the two, right? We choose 0. Evaluate it on fx. Okay. When a is 0, f at 0. So f is the first function, we call it fx. When I substitute x equals 0, I get 8. Likewise, gx, the second function, I substitute 0, I get negative 2. So obviously, blue is f because it's higher value at 0 and g is lower value at 0. So between negative 2 and 5, you can choose any point and you notice blue is above and red is below. So any number had you chosen between negative 2 and 5, you would have found out that f has higher value. All right. So on the interval -2 to 5, gx is smaller than fx. So therefore the required area is integral -2 to 5, the higher function f minus the lower function g. So we have simply rewritten the expression x squared plus 2x minus 8 for f, and gx is 2x squared minus x minus 2. Be mindful of taking the subtraction. When you take subtraction, you need to write parentheses on the right. Simplifying this fetches us this expression, negative x squared plus 3x plus 10, integral -2 to 5. Take an antiderivative of each term, and these are the limits. Finally, substitute at the higher level, subtract, substitute at the lower limit. Okay, be mindful of the signs. Okay, and then after all that, I receive this as the area. So the area, it seems, is 57 and 1/6. So I'll say 57 plus 1/6. Okay, that's correct. I'll continue on the next problem in the next video.